Hi there! Let us try to solve this given linear system. The solution of this given linear system would satisfy both equations, not just one, but both equations. Now these two equations are called linear equations in two variables because number one, we have two variables here, x and y. Number two, their exponents are 1. That's why they are called linear. And number three, if we are going to draw their graph on the Cartesian plane, both of the graphs would be line. And speaking of solution, the solution for this given linear system would be the intersection of the line. So it's a point. So we were going to solve for x and y in this manner. One process you could do is by graphing, but we will not be graphing here. Instead, we will be using elimination method. Now, before I will use the elimination method, notice that our two equations here are expressed in general forms. General forms in the sense that your right hand side are both equal to 0 and you would see constants on your left hand side. Now no need to worry about that. We could also start by coming up with a standard form where we remove the constant on the left hand side and appear it on the right hand side before we could apply the same processes as we did in the previous video. So to start, let me write here the equivalent standard forms of the two equations. So your first equation would be 3x plus 4y, and then you're going to add 4 on both sides, removing the minus 4 on your left hand side, but it will appear on this side here. Now doing the same thing on the second equation, you will have 6x minus 2y, adding both sides by a 3, you will have 3 here, and a negative 3 on the left hand side is now removed. So here we have two equations which are expressed in standard form, similar to our general forms already given. Now to use the process of elimination, it's very important for us to examine the coefficients of the variables because we could multiply a certain constant to one of the two equations or even both of them, so that when we add the two equations, one of the two variables will be removed. Here we could see that the coefficients of x are in multiples, so 3 and 6. The same goes with our y. We have 4 and minus 2. So you could go both ways. But let me just try to eliminate y. Okay, because the sign of the second coefficient of y is already negative. So I don't need to multiply any of the two equations by a negative number. Instead, I could multiply the second equation by 2. And then I could come up with this new version of the system. So the first equation is still first equation. 3x plus 4y is equal to 4. But the second equation is where we multiply a certain constant, which is 2, on all the terms, not just for y, not just for 6x, but for all. So this would mean we have here 12x, the minus 2y becomes minus 4y, and the 3 becomes 6. Now if we're going to add these two equations, we could see that we could now remove y, and we could solve for the value of x. That value of x later will be used to solve the y, and we could verify it later as well. So when we add this, you will have 15x is equal to 10 on the constant. Dividing both sides by 15, so x is 10 over 15, or in lowest terms, you will have 2/3. Now you see that the value of x is in fraction. Don't need to worry about that because just like any other system or even in the Cartesian plane, we also accept fractional answers. So we just need to use this and substitute this on our given equations to come up with the value of y that would be paired with this, if there is, of course. Now we are going to use any of the two equations, but for this case, I'm going to show the substitution of this value to both of the equations, okay? So that we could really verify. But of course, you could just do for one. Now, say another thing, substitute this value of x on the original given, okay? Because there might be some process in moving from general form to standard form, or even this here, when we multiply a certain constant to second equation, there might be some concerns or problems in the process, and you could only say that there is if you could not come up with the same values of y in our original equation. So let me use the original equation for the first. So we will have here 3x, that's a 3, plus 4y minus 4 is equal to 0. Simply substitute the given, and you will have, not the given, the value of x. So you have here 3 times 2/3 plus 4y minus 4 is equal to 0. Let's continue. Of course, you could multiply that. You have 2 plus 4y minus 4 equal to 0. 4y minus 2 equal to 0. Add both sides by 2. 4y is equal to 2. And when you divide both sides by 4, you will get 2/4 for y, or in lowest terms, 1/2. This is now the pair of 2/3 being x, so this is now the value of y. But then again, as mentioned, we can verify it further by using the same value of x on the original second equation. Okay, this is a verification process. You don't need to worry about this much, but this is just a practice so that you would really sure about your answer. Your second original equation is 6x minus 2y minus 3 is equal to 0. So you have 6 times 2/3 minus 2y minus 3 is 0. You divide that, that's 2, right? 2 times 2, you will have 4 minus 2y minus 3 equal to 0. You will have negative 2y plus 1 equal to 0. Subtracting both sides by 1, negative 2y is equal to negative 1. Dividing both sides by negative 2, you will have a result of positive 1/2. You could see that the value of y is the same in both of the equations using the same value of x. This means that I could finally say that our solution, being a point in the Cartesian plane, is a combination of x being 2/3 and y being 1/2. So this is now the solution of this given linear system and this would be the point of intersection on the two line graphs that can be drawn using these two equations. Now, you could stop here, or you could pause for a while, but let me move forward for some of us who would really like to see another verification. Let's do a little bit of checking. This checking here allows us to really verify if our answer is correct or not. In checking, we just simply need to use our x and y values on our both original equations, and we just need to come up with a balanced equation. If it will not be an equation, even if you're really sure about this, then definitely there's no solution. Let me use the first original equation. You have 3x plus 4y minus 4 equals 0. Substituting the two values, 3 times 2/3 plus 4 times 1/2 minus, minus 4 must be 0. Question mark? I'm using question mark here because we are still in the verification process. And even if it's too obvious to simply continue, the goal is to make sure that both sides will be the same. So yeah, this is actually 1, this is 2. So you have 2 plus 2 times 1, 2, minus 4, question mark 0. Of course, 0 is equal to 0. That's very obvious. Now, we could even use the second equation. By the way, but with this, we're already sure that the solution is really a solution. But in the second equation as well, 6x, that's minus 2y minus 3 is equal to 0. So 6 times 2/3 minus 2 times 1/2 minus 3 question mark 0. So this is 2. This is just 1. So 2 times 2, 4. Minus 1 minus 3. Question mark 0. Of course, you will get 0. Check. Equal to 0. So we have verified it further. The solution for this given linear system is at 2/3 and 1/2. We use all of these operations and verifications, but we started with coming up with the standard form from this given general forms. Thank you very much for watching.